This figure is showing the pH scale in a visual representation. The pH scale, as we said a few moments ago, relates to values ranging from 0 all the way to 14. Values between 0 and 7 are said to be acidic. Values between 7 and 14 are said to be basic, while values at 7 are said to be neutral. And again, neutrality means the concentration of hydrogen ion is equal to the concentration of hydroxide ion. So as the pH number increases, the concentration of hydrogen ion decreases. And that's an important relationship to remember. Now, the numbers that are shown in the middle are written in a form called scientific notation. So 10 to the minus 1 is 0.1, 10 to the minus 2 is 0.01, 10 to the minus 3 is 0.001, and so on. So you can see as we go down, the concentration of hydrogen ions is getting smaller and smaller. And we said as the concentration of hydrogen ions gets smaller, the pH numerically rises, which means the solution is becoming more basic, or another way of saying it is less acidic. Now, it's going to be very important in our bodies to maintain homeostasis of pH, at least in certain regions of the body. So we're going to come back and talk about how does the body achieve that. The other thing that I wanted to mention to you about this particular figure had to do with the actual concentration change in hydrogen ion per unit change of pH. Because if I told you that the pH in your mouth was 7 and the pH in your stomach was 2, the difference of 5 units doesn't sound very impressive. But you have to remember that the pH scale is a logarithmic scale, which means small changes in concentration can correlate to big changes in pH. So for example, you remember that I said pH 2, the concentration of hydrogen ions was 0.01. For pH 7, the concentration is 0.000007, which is obviously quite a bit smaller. So when we say the pH in your mouth is 7, that means there's a relatively low concentration of hydrogen ions compared to the pH in your stomach, which is pH 2. How great of a difference is it? For every 1 unit change on the pH scale, there's a 10-fold concentration difference in hydrogen ion. So in other words, at pH 7 versus pH 2, what's the concentration gradient difference? So remember, for each number we move, it represents a 10-fold change. So 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. So it sounds much more dramatic if I tell you that the concentration of hydrogen ions in your stomach is 100,000 times greater than the concentration of hydrogen ion in your mouth than saying the pH of the stomach is 2 and the pH of the mouth is 7. So again, small changes in hydrogen ion concentration can have big changes on the actual pH value.